I sometimes just find myself staring up at the night sky thinking about Mars. And I try to square this image we have now of a cold, dusty world with the evidence of its past. I mean, we see these enormous geological scars, these massive valley networks, and of course the delta in Jezero crater. They must have been formed by just staggering amounts of water.
Oh, absolutely. The
That-
evidence is, it's overwhelming.
Right?
Geologists estimate that early Mars might have had what we call a global equivalent layer of water, a GEL, that was maybe up to 1,500 meters deep.
An ocean's worth of water, basically,
Ah.
carving out the planet.
Exactly. An ocean carving those features over a very, very long time.
But that leads us right to the famous Martian mystery, doesn't it? The faint young sun paradox.
That's the one.
The sun was about 30% dimmer back then, so it just wasn't powerful enough to warm the planet above freezing with CO2 alone. So if carbon dioxide wasn't enough, what was the critical ingredient? What flipped Mars from a frozen world to a river world?
The answer, according to some really new combined climate and photochemical models, is hydrogen, H2.
Oh,
It acted as a kind of super greenhouse gas supplement. And the fascinating part is where it came from. It wasn't from the atmosphere, but from the crust itself.
wait, so the rocks were fueling the atmosphere.
Precisely. It
Yeah.
was this incredible planetary feedback mechanism. You had water interacting with iron-rich rock deep in the crust.
Okay.
And that chemical reaction, iron oxidation, as a byproduct, it bakes out hydrogen gas.
Wow.
And that H2, maybe supplemented by some volcanic activity, created these warm, humid periods.
So not a permanent tropical paradise, but episodes of warmth.
Exactly. Episodic. They think each warm event lasted at least 100,000 years, which, adds up. All told, maybe about 40 million years of cumulative flow time. That's the perfect time scale to sculpt those valleys we see today.
It makes so much sense. So understanding the chemistry is one thing, but then there's a new finding that tells us where all that water went, right?
Yes, and this is a huge step forward. Scientists have just released the most detailed map yet of Mars's ancient interconnected river systems.
And they found these mega watersheds.
That's right. The map identifies 16 major interconnected river basins. And to be a mega watershed, each one has to be larger than 100,000 square kilometers.
That's immense. But I read they only cover a tiny fraction of the planet's surface.
Only about 5% of the ancient Martian terrain. But, and here's the key part for the search for life, get this, those 16 basins account for roughly 42% of the planet's total river-eroded sediment volume.
So all the good stuff got washed into just a few specific places.
Exactly. Think about the Amazon here on Earth. These huge river systems become ecological hotspots because they concentrate nutrients. On Mars, these megabasins are the prime targets. They collected and concentrated the entire planet's chemical history.
And concentrating that history is exactly what we need to analyze, which of course relies on some pretty intelligent systems to make sense of the data.
It does. And actually, before we dive into that data, I wanted to quickly mention our sponsor. If you or your business needs help with AI training, automation, or software development, you should check out Embersilk. They're experts at figuring out where AI agents can make the biggest impact. You can find out more at embersilk.com for all your AI needs.
So let's talk about those hotspots, specifically Jezero crater, where Perseverance is right now. What is it finding that links back to this model of sustained ancient water?
Perseverance has given us some powerful confirmation. For one, the discovery of white, aluminum-rich clay fragments, a mineral called kalinite.
And that's significant because
Kalinite requires massive, sustained water flow to form. We're talking millions of years in a wet, rainy, almost tropical-like environment.
wow, that's definitive.
Gets even better. The Sapphire Canyon rock sample is right now the best candidate we have for signs of ancient life.
What makes that one so special?
It contains these tiny chemical specks. The science team calls them poppy seeds and leopard spots. And these specks are highly enriched with iron, phosphate, and sulfide. On Earth, those specific compounds are classic byproducts of microbial life. Microbes literally leave these chemical fingerprints behind.
So the puzzle pieces are all fitting together. We're not just learning how Mars was warm enough to be wet, but we now know exactly where to look for the life that might have come from it.
That's it. By understanding the episodic warming and mapping these 16 megabasins, humanity now has a powerful, precise roadmap. It's guiding our missions directly to the most promising sites to find those definitive traces of life.
That ability to just precisely target our search based on these breakthroughs is, well, it's just truly inspiring. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.